During the last class, we were discussing about functions and recursive functions, etc., etc. Then in that case, we saw how to pass variables, the scalar variables, that is a variable with the single values, not an array. Simple scalar variables, how to pass it to functions and how to get output from the function, that we have already seen. As I said, we have already discussed about the recursive functions and how recursion can be used for finding factorial of a particular number. Now, in today's session, we will discuss about passing arrays to functions, that is a list of numbers or a list of items of the same type, that constitutes an array, that we have already studied, and how an array can be passed to the function. That is the first thing that we will discuss today, and we will discuss about the structures. Just an introduction to the structures will also be discussed today. And passing arrays to functions is similar to passing the scalar variables as arguments, as parameters to functions. The only difference is that along with the name of the function, name of the array, we have to give as an additional parameter, we have to give the total number of elements in the array. So that is how the passing arrays is different from the passing scalar variables. In the case of scalar variables, we have to give only the value associated with that particular scalar variable, only the name of the scalar variable. But in the other case, in the case of arrays, there will be at least two parameters required for passing an array to a function, a complete array, if you want to pass a complete array to a function. But the array members, if you want to pass, or if you want to pass a particular member in an array, say the fifth element in an array, so in that case you can directly pass it without any difficulty, as in scalar variables. As we pass the scalar variables, in the same way we can pass the array members also. The array elements can be passed in the same way. But if you want to pass a complete array, that is the entire array is to be passed, in that case we have to give the name of the array as well as the size of the array as arguments. So that is the thing. Now let's see an example. So here is a function call. This is a function called the average x comma list. So where x is the number of elements in the array list. List is an array. So this is a function call, or invoking a particular function. That is, average is the function, and we are calling the function average within another function. It may be in main, or it can be in another function. So we are calling the function average, and the parameters used in average are: one is an integer, x is an integer which represents the number of elements within the array list. List is the array. So this is how a function uses the array elements, not the array elements, the entire array as its parameter. So the function header corresponding to this particular call, that is the function header for this particular average function, should be something like this: float average int n float num with a square brackets. So this means int n. Int n means a variable of type integer is to be passed as a parameter or as an argument to the function average, and this corresponds to this x. See, this int n corresponds to this x. So this integer value should be the number of elements within the array, that is num. This is the array num. So float num. So it is the array num contains all the floating values. All the elements within the array num is floating point values. So within this floating point array, that is num, we have to give the square brackets also. This square bracket is used in order to represent that the second argument for this particular function average is an array. If we doesn't put this square bracket, then this particular value, this particular member or the parameter will be taking only floating point values. If you want to pass an array, an entire array to this, then you have to give the square bracket also. So in that case, the function average will be having two parameters, one representing the size of the array and the second one the name of the array itself. So in the formal argument declaration, that is within the function prototype, the formal argument declaration is within the function declaration, that is the function prototype. In that case, it needs a set of empty square brackets to indicate that num is an array. That is the same as the function header. The function header as well as the function declaration both should be having a pair of square brackets, empty square brackets, in order to indicate that the second variable, or it can be the first also, no problem. The order of these two parameters can be reversed also, that is the first is the array and the second is the integer. That is also possible, no problem. So in the function declaration also, a set of empty square brackets should follow the array name. So now let's see an example. In this example, what we will be doing is we write a C program to find the largest and the second largest numbers among a list of numbers using functions. So we are using functions here, and there is a list of numbers, and we want to find out the largest as well as the second largest numbers among this list of numbers. So let's see how this can be done. So here is the program. So we start with hash include stdio.h and hash include conio.h. Then the int main void, we are starting the main function. We are not declaring the numbers, I mean declaring the functions before the int main void. It is not necessary always to declare the functions before int main void. Within this main function, within the main function also we can declare it. So like this, here it is declared, these two lines. See, these are the two functions that is being declared. Int largest, int num. So this is the array, int num, that is the array, int n, that is the size of the array. So int second, int num, then int n. So these are the two functions which uses an array as its parameter. So the function declaration or the function prototype can be inserted within the main function also. It need not be always outside the function. In most of the cases we put it outside the main function, but we can put it inside the main function also, no problem. So now we have two integer variables, int x and n. Then there is an array, int num, that is the size of the particular array is 50. So then we puts, that is we display the question how many numbers in the list. It should be less than or equal to 50 because the maximum number of array elements in the array that we have declared is 50. So then we scanf the size of that particular array. So that is n. So n takes the value of n will be the number of elements within the array. So then we puts in the means it is displaying the message, displaying that particular message on the screen. So give the numbers one by one. So we have to give the numbers one by one. So for x equal to 0, x less than n, x plus plus. So in this case x acts as the counter. X is the variable that is used as the counter, and using x and iterating through x, we are scanning each number that we enter into the array. So the array is fed with the numbers that we enter. So that is scanf %d and present num x. So this this is because each element, each position within the array is being assigned with a specific value that we are entering. That is what this particular line does. It is scanning the or reading the value from the user input. So the user input method is input device is normally our keyboard. So from the keyboard, the value that is being entered is read by the program, and it is being stored into the array. Then we just try. So these things we can actually right away give away with, because that we will discuss later. Yeah, okay. So after the function call, that is also not required right now. So that also we will discuss later after the things. Okay. Then we go for the printf largest number %d, second largest number %d. So then the largest num n. So this is the function call. Here we call the function largest. The largest function is the function largest. The function name the largest is called here with the array name, that is num is the array name. So num as well as n is the size of the array. So with both the values in place. Then the second largest. In order to find out the second largest, the second function, the function second. The name of the function is second. So that particular function is also called with the array name as well as the number of elements within the array as its parameters. So by now you might have understood what is the difference between puts and a printf. In puts we are entering only a string. We can enter or we can display only a string. But when using printf, you can format the output also. Format the output in the sense you can give %d, etc. That is the placeholders also can be given. So whenever you want to print a specific value or not just the string, but some value is to be assigned to a specific placeholder. In that case you have to use printf, otherwise you can use puts. So then finally it is get ch. This one is get ch is normally used in cases where the user has to type in any character from the keyboard in order to exit from the program. So that is why get ch is commonly used. So the next is the functions. The two functions, we have two different functions. One is the largest. In the largest, int largest, this is the function header, int largest, int p. So here the function, the name of the array in this particular function is p, and the size of the array is k in this case. So that the values that is passed from this function call, the num will be mapped with p as well as n will be mapped with k. So int big equal to 0, I, big is to find out the biggest number, the largest number. In order to find out the largest number, we use the big. It is initialized with 0 because we assume that all the values in the array is positive values, positive integers, no negative values are being used. So for I equal to 0, I less than k, I plus plus. So k is a counter here. I is the counter here, and k is the total number of elements within the array. Then we are checking whether p of I is greater than big. If p of I is greater than big, then we replace big with p of I. So big will be assigned with the value p of I. So then this one also we can so why it is there, that we will discuss later. So big is equal to p of I. So return big. Now we have to return the big. So the largest value is, the largest number is returned. Then in the second function, the function second. So int second, it returns in integer value. So the function second returns an integer value, because all the array elements are integers. All the array elements are integers, so the value that is being returned by the function will also be an integer. So then into q, so here the name of the array is q and the size of the array is m. So here we are calling second as num and n, second with the parameters num and n. So num is mapped with the p, and I mean q, and k is n is mapped with the m. So here again we search for int sec equal to 0. So sec is the second largest number. In order to store the second largest number, we use the variable sec, that is initialized to 0, and I is the counter. For I equal to 0, I less than m, I plus plus. For qi is not equal to largest qm. So that is, if qi is the largest one, then we have to omit it, because if it is the largest, we may not be able to find out the second largest. So if qi is the largest one, then we are not checking whether it is greater than second or not. So each time we encounter with a specific qi value, we are again calling this particular function, the largest function. The function largest is again called whenever we encounter with a specific value in the qi. That is, for each value of for each element in qi, we call the function largest again and again. So largest q comma m. So that is checking whether qi is the largest value or not. So the largest value is being checked. If it is not the largest value, if qi is not the largest value, then we check if qi is greater than second. If it is greater than second, then second is assigned with, or sec is assigned with qi. So that is how this particular function works. So we have another way of doing it. Instead of checking each element as largest, we can find out the largest and store it in a separate variable, and then we can check whether qi is that equal to that particular value or not. That is also possible. So in this case, each and every time a particular number is checked from qi, I mean q, the list q, then we are checking, or we are calling the function largest. That is actually time consuming, as well as if the size of the array is too large. If the size of the array is very large, in that case that is too time consuming. But in our case, because our programs are very small and we will be entering very small numbers, so that is okay. But in the case of large programs, this way of doing is not advisable, because each time calling another function is very time consuming. So instead you can use it, you can call this function only once and store the value, that is the largest value, in another variable, and then you can check that value with all the elements in the queue. So now let's compile this one. There is no error, so we are running it. So how many numbers in the list? I am just entering only 5 numbers. 5 give the numbers one by one, so I am entering. So I have entered 5 numbers, 8, 4, 5, 3 and 0. So the largest number is 8 and the second largest number is 5. So this is how an array is being passed as a parameter into function. So now this is it, but there is some difference. There is some difference between passing a scalar value as a parameter to function, as well as an array as a parameter to the function. In the case of a scalar value, you know that a copy of that particular value is created inside the function, and the value of the original variable doesn't changes inside the calling function. Even if we change the value of that particular parameter inside the called function, the value of that particular parameter or the particular variable doesn't changes inside the calling function. But it is not the case with the arrays. When we are actually passing an array, we are not creating a copy of that particular array. That is, in this case, see largest num n. In the normal case, if this is a scalar value, if this is a scalar value, in that case the value p will be getting a copy of number. But this is not a scalar value. This is not a scalar value. But in the case of n, it is the case. That is, a copy of n will be created as k. That is, the value of n will be getting as k. So any change that we make inside this particular function for the value k will not be reflected here. But it is not the case with the arrays. In the case of array, we are not actually creating a copy of this particular array here. Instead, we are only passing the address of the elements, of the array into this one. So what we actually does is, inside the function we are actually addressing, or we are actually accessing the original elements in the array. So if we change an element within this particular array, I mean within this particular function, then that change in value in the array will be reflected here also. That is, it uses the same copy. It doesn't create another copy. It uses the same thing both in the calling function as well as in the called function. So for that one, let's check it. So here I am giving a printf statement. Before calling the function, I am giving a printf statement in order to print all the values within the array. So before the function call, all the values are printed. So for x equal to 0, x less than n, x plus plus, print %d num x. So all the values of the num x, I mean num array, the num array, all the values are printed or displayed. Then after the execution, or after calling this particular function, after calling this both the functions, largest number n and second largest number n, we are again printing the values. We are printing the values after the function call. All the values are again displayed, but we haven't made any changes to the value inside the function. No changes to that particular array elements are being changed done inside the function largest. So in order to make a small change, we are making the p of 1 as 1, I mean 0. So the value at the first location, that is the second position, that is 0 and 1. So the second position is being changed to 0. That is done in the largest function, that is the function inside the function largest. And inside the function second, we are changing the second position, I mean second location, or the third position as -1. So this is the two changes that we made for the array inside our functions. So now let us run it. So now how many numbers in the list? I am giving 6 numbers. So I will be giving no 0 as well as no -1s. 9, 5, 6, 4, 8 and 3. So before the function call, the elements were 9, 5, 6, 4, 8 and 3. Largest number is 9 and second largest number is 8, that is using the function calls. Then after the function call, the values are 9, 0, -1, 4, 8 and 3. See the difference. Here 5, it was 5, in the first position it was 5, here it became 0. Here it was 6, here it became -1. And we changed, or we made the changes within the function itself. We made the changes within the function. and the changes was not made inside the calling function, but it was made inside the called function. So that particular changes to the array elements within the function is reflected in the calling function also. But this was not the case when we used the scalar variables. Whatever changes we make inside the calling function, inside the called function, is not being reflected inside the calling function. So that is the difference, that is one of the difference between passing an array as an argument as well as passing a scalar value as an argument. So in one case, the first difference is along with the name of the array we have to give the size of the array also. The second difference is in the function call, in the function we are creating a copy of the value in the case of scalar parameters, but in this case of array parameters or parameters as array, we are not creating a copy of the array. Instead we are working with the array itself, with the original array itself. So that is the difference. So now we move on to the structures in C. The structures in C is actually in order to handle the different data types together. In an array we have seen that all the elements should be of the same type. All the elements within an array should be of the same type. If it is an integer array, then all the elements within the array should be of integer type. If it is a character array, all the elements within that array should be of character type. But there are situations where we want to store different types of data, like it can be a character, or it can be a string, or it can be an integer value, it can be a float value, or it can be a long value, etc. together. That is situations like employee details, the name of the employee, the number of the employee, the date of birth of the employee, the salary of the employee, etc. are different data types. The name of the employee is a string. The employee number can be a combination of alphanumeric characters, so it can be a string, or in some cases it can be integers also, so it can be integers. Then the salary will be a floating point value, and the date of birth, if you want to store the date of date of birth or the date of joining, in that case you have to, it should be having another 3 different data types, because the date, the month and the year. So the date and the year can be integer types, and the month can be integer, it can be represented as integer, or it can be represented as string or character array. So then another such a situation is inventory positions or student records, etc., etc. So the different data types of data elements needs to be handled just like a single data element. That is what we have to do. That is, while using the structures, different types of data can be handled just like a single data. That is, a student record, if you consider a student record, it should be a single data. A student, his name, his roll number, his marks, his date of birth, etc. All these things should be considered as a single data. So this type of data type, this is a user defined data type actually. This data type is called a structure. That is, data type, structure is another data type. It is a conglomerate data type. It is also called a conglomerate data type because it combines many different data types together in a same name under one. A group of variables of different data types are considered under the same name. That is why it is known as a conglomerate data type. So it is a structure. The name of this particular conglomerate data type is a structure. Now, the structure can refer collectively to a set of data items that differ among themselves in data type. So that is different data types. It can be integer, it can be float, it can be double, it can be character type, or it can be an array itself. An element within the structure can be an array, no problem. So The individual data items are said to occupy fields within the structure. So a field is the space occupied by the individual data items in a structure. So then the structure may contain fields of different data types as well as arrays, pointers or other structures also. That is, a field within a particular structure can be another structure. If we if we have to represent a date, there is no data type such as date in C. So in order to store that date, what we need is we must be having three different data types together or three different elements together. The date, then the date, the day, then the month, then the year. So these three things together can be a structure. And in the case of defining or declaring a particular structure as a student record, in that case the date of birth can be this particular structure. So that is, a structure can be a member or a field within another structure. So the individual elements within the structures are called members. The individual elements, the entire elements, so within the structure are called members. So the general form of structure declaration is like this. The general form of initially we have to give struct, it is a keyword. Then we start a double braces, an opening double brace, then member 1 as well as member 2. So this member 1 as well as member 2 will be different data types. Likewise, how many data types you have to give or how many members you need, all these things you can define. Then the the double quotes ends, then the variables list, the list of variables of this type, list of variables of the structure type data. So the struct is the keyword indicating that a structure definition, and variables list is the names of the structure type variables, the different variables of the type struct that we have created. So then individual fields are declared inside the braces separated by a semicolon. So individual fields, they are the members. So member 1 is declares the first field and member 2 the second field and so on. So that way we can declare different members or different fields within a single structure. So the field declaration is written in a manner similar to the variable declaration, that is like a data type field name. So this is the way how a particular field is declared. This is the same as how we declare our normal variables, our scalar type variables in C. So where field name is an identifier and data type is the type of data that is being stored inside the field name. So then there is no difference between the terms structure definition as well as structure declaration. Both are used interchangeably. So the structure definition as well as structure declaration are the same thing. So an example structure is given here, or an example structure declaration is given here. So struct, the keyword is here struct, then the double braces starts int number. So it is a number, that is an integer value. The name of that particular variable is number. Then char title 30. So it is a character array. The name is title. Then another character array. So that is char author 20. So it is another character array. Then float price, a floating point variable, that is price. Then the double quotes, the double braces ends, then book 1 as well as book 2. So book 1 as well as book 2 are two instances of this particular structure. So book 1 is a variable and book 2 is another variable, and both these variables will be of type this particular structure. That is, book 1 will be containing all these 4 fields, as well as book 2 will also be containing all these 4 fields. And how to access individual fields inside a structure, that we will discuss later. In the next class we will discuss.